I welcome you all once again for the next session, where in the last session we were discussing about factorial of a factorial program using iterative approach, and we saw that in the previous session the details regarding how a recursion works, what is a recursion, and which kind of a problem can be solved using recursion. And all, as well, we have also seen the different cases what a recursion program must include, that is base case and general case. And we've also seen one of the program which we have solved using iterative approach. And now we are going to see the next concept, how the same factorial program can be approached using recursive methodology. So coming to this program, as we all know that recursion is nothing but calling the function within the same function. So now why do we call that function within the same function is we want to reduce the problem into smaller instances. So in fact, if we want to reduce the problem into smaller instances, we need to keep on calling the function within itself. So coming to this program, in first let us see, as the execution begins from main, we'll see the statements one by one. So the number whose factorial has to be determined has been stored in a variable called as number, and it is an integer type, and the output of this particular program will be stored in a variable called as fact, and it has been mentioned with the type long. I'll come to this point later on, why we have mentioned the data type of the factorial variable as long. And then we are going to ask the user to enter the number whose factorial has to be 5. So the first step, what you are now going to do is taking that number, we pass that number as a parameter to a function called as factorial. So as soon as this line is encountered, this factorial of a number, this function has been called inside main function. So let us just show this particular step one by one. So what happens when the recursion occurs? How does the flow of the program goes? So what happens when the factorial of 5 is called is, so this is what happens. So first we call the function inside the main function, that is the number, the value what for which we need to find out the factorial of number is stored in a variable called as number, and I have taken as an example of number as 5. So 5 is passed as a parameter to the function factorial. So first it looks that whether the function has been declared. Yes, function has been declared, and the name of the function is factorial, and the parameter what it accepts is integer. So we are passing the same. And since this has been assigned to an fact variable, and fact is since of type long, even the return type of this particular function should also be long. Why we have mentioned long is in the sense, long is nothing but a long format of integer. So integer has a capacity or a range to store the positive number of range 2 to the power of 32. So but when it comes to a factorial of a huge number, that will be beyond that range. So a normal integer variable cannot hold that much big number. So if it has to hold that number, then the data type should be long. So that is the reason why the output variable fact has been mentioned as of type long. Okay, and since it is called, and the value whatever this function returns is saved in a variable of type long, even the return type of that function is been mentioned as long. So let us see how this particular factorial of 5 determines its output once this function parameter is passed to the function definition. So now you can see that the number 5 is being passed to the variable n. So n is an formal parameter and number is an actual parameter. So the actual parameter number value is stored in formal parameter n. So now the first step what we see is it n value is 0. Okay, if n value is not 0, then it goes to the else case, and carefully observe that what we are doing it in the else case. In the else case, we are calling, since it's not 5, n is not 5, we go to the else case, it returns n into factorial of n minus 1. So this is the case where the problem is getting reduced. So what is the value of n? N value is 5 and into factorial. So we are calling the function. Okay, 5 minus 1 is 4. We are calling 5 into factorial of 4. So now if you observe, we are calling this particular function inside the same function. So you can see that calling function and called function are one and the same here. So that is what is the definition of recursion says, that we need to call the function within itself. Such kind of a function is called as a recursive function. And when you see this recursive function, what happens is that each time when this particular else case is encountered, we are reducing the program. So now 5 into factorial of 4. So we should again call the factorial of 4 function. So now this 4 will be saved in n. Okay, so now the value of n is 4. Now again it checks that is it n value is 0. No, n value is not 0. So again it goes to the else case. What happens in else case? We are again reducing the problem. The actual output what you need to get was factorial of 4. Since factorial of 4 is a complex problem, we need to reduce that problem further. So we are going to the else case. In else case, what we are doing, we are finding out n into factorial of n minus 1. So this particular statement again gets reduced to what is the current value of n? Current value of n is is 4. Okay, so if you can see that the current value of n is 4 into factorial of 3. That is what is the factorial of n minus 1 determined. So if you can see here, so what happens is this particular line gets saved as 4 into factorial of n minus 1. So that's n into n minus 1. So n minus 1 is 4 minus 1. That is, it gets reduced to 3 minus 1. Okay, so now what you need to find is so as once we found 4 into factorial of 3, now we are calling a function factorial again with the parameter as 3. Now n takes the value as 3. Now again it checks this case. Is it n value is 0? Right now n value is 3. Okay, so it goes to the else case again. Again in the else case, the problem is further reduced. So you can see that what is the current value of n? The current value of n is 3. Okay, so again it's divided into 3 into factorial of n minus 1, that is 3 minus 1, which is 2. Do we know the answer of factorial 2? It's quite complex. We need to compute them. We don't know the direct answer of factorial of 2. So again the function is called with a parameter as n, 2, which is stored in n. Again it checks this. Is it n is equal to 0? No, n is not equal to 0. So it goes to the else case. Again it find out n into factorial of n minus 1. So what is the current value of n? The current value of n is 2. 2 into factorial of 1. Okay, 2 into factorial of 1. Do we know factorial of 1 directly? Yes, we know, of course, it is 1. Let us further reduce, because there is a scope to reduce the problem further. So we will further reduce it. So what is the value of factorial of 1? So now the n value is, number is 1 and n value is taken as 1. Is it equal to 0? No, it's not equal to 0. So what we are going to write? Else case, we come to again return statement. So in return statement, we are going to write 1 into factorial of 0. What is the current value of n? The current value of n is 0. So now n value is 0. So now this condition becomes true. And for this condition, we are not reducing the problem. We know the answer directly. What is the factorial of 0? It is 1. So we are returning 1. So if you can recall what was the base case was, base case is a situation which has a direct answer to the problem. Okay, and what are general cases? General cases are nothing but which keep on reducing your problem. So you can see that we started with factorial of 5. Each time when we encountered else, we were going into the general case. What was in general case happening? It was just reducing the problem smaller and smaller. So you can see that we started with factorial of 5, then we moved on to factorial of food, we reduced it to factorial of 0, and we stopped our general case. Why? Because we know the answer of factorial of 0 directly. So what is a factorial of 0? It is 1. So now this particular factorial of 0 is the one which was called recently, and for that call the answer what it was returned was 1. Okay, so now this is replaced by the value 1. Okay, so this complete statement is been replaced by 1. So now 1 into 1. So 1 into 1 is the answer is 1, and this is returned to the next case which was called. So the next recently called case was factorial of 1. So this answer is returned as an answer for factorial of 1. Okay, so now what is 1 into 1? It is 1. So this will be returned as the answer for factorial of 1. Okay, now 2 into 1. So 2 into 1 uh, is the answer for the previously called function. What was the previously called function? Factorial of 2. So what is the value of 2? 2 into 1, it is 2. So this will be replaced by the answer as 2. So what is 3 into 2? 6. This is the answer for the previously called function. What was previously called? Factorial of 3. Okay, so now this will be written as the answer for previously called function. So now if you can observe, 3 into 2 is 6. So that will be treated as an answer for factorial of 3. So what is 6 into 4? 6 into 4 is 24. 24 is an answer for the previously called function. What was previously called? So previously the function which was called was factorial of 4. So 6 into 4 is 24. So this is the answer. So 24 into 5. 24 into 5 is 120. So 120 was going to be shifted to the previously called function. Now the previously called function, when we called actually factorial of number, what was the value of number? It was 5. So this is where it will shift this 24 into 5. What is 24 into 5? It is 120, and this entire thing will be replaced by the answer of 24 into 5, that is 120. Now the 120 will be saved in fact variable, and we are printing the result of that fact. So factorial of 5 is getting reduced to 120. So this is what a recursion approach is. So when you can see the recursion approach, when we started with factorial of 5, we went on to the function with taking the parameter value as 5, but within the function the number got reduced from 5 to 0, because the general case suggests that if the problem is complex, yes, of course factorial of 5 is quite complex, so we need to keep on reducing it. In the general case, in general case you can see that n minus 1, each time when you go to a general case the value of n is being decreased. Okay, and once, when does this general case stops? At one point of time n kept on reducing, one point of time n becomes 0. When the n value becomes 0, we know the direct answer, and such case is called as base case. And if you remember the theoretical session what we have explained about recursion, I have clearly said that every recursive program should have at least one base case. At least one base case. There can be more than one base case, but mandatory is that it should have at least one base case. Because if you don't have the base case for recursion program, then the recursion might end up in becoming infinite in nature. So this is what is a factorial program to using recursive approach. Okay, fine. Thank you.